Hello students, in today's class we are going to see conic sections, what is eccentricity and how can we going to draw the conic sections by using eccentricity method. Okay, so as I said, conic sections, ellipse, parabola and hyperbola are called conic sections. These conic sections can be obtained by cutting a cone using a cutting plane. Okay, for example, here in this diagram a cone is intersected by a plane. Okay, the section plane passing through the two extreme generators. Okay, so if we cut this cone like this, we will get a ellipse. Okay, similarly a cone which is again intersected by a plane, and the plane is parallel to one generator and it is intersecting only one generator and the base. Now you can see we can obtain a parabola, and then we have another cone in which the section plane is cutting the cone parallel to the axis, and we obtained a hyperbola if we intersect the plane like this. Okay, so by cutting a cone, we can obtain ellipse, parabola, and hyperbola. Due to this, we are calling these sections as conic sections. And then, so what is eccentricity? So, eccentricity is the ratio between the vertex to focus divided by the vertex to fixed line. Okay, the ratio between these two. So, this is fixed point or focus, and this is the vertex can be along the ellipse or parabola, hyperbola. So this is 1 and this distance is x or 1. Okay, and then this is fixed line and this is moving point, this distance is 2, or we can name it as x and y. The ratio between x and y is called eccentricity E, or Vf by Vc. So we can call it as Vf by Vc. So the distance between vertex to focus divided by vertex to directrix. Okay, this is the eccentricity. For ellipse, eccentricity will be less than 1. For parabola, it is equal to 1. And for hyperbola, it is greater than 1. Okay, so now we are going to see the steps to draw the ellipse by using eccentricity method. So here the distance between the fixed line to focus is given, that is 50 mm, and a point P is moving in a plane such that the ratio of its distance from F and line AB remains constant and equals to 2 by 3. That means the eccentricity E will be 2 by 3. Draw the locus of point P. Okay, so we are going to draw the ellipse now since they have given the eccentricity ratio. So first what we have to do is we have to draw the fixed line. Fixed line is called directrix. Okay, and then the horizontal line, that is the axis of the ellipse, parabola or hyperbola, we are going to draw. So this is the axis, the horizontal line is called axis, and then we are going to fix the focus at 50 mm away from the directrix. So I have fixed the focus. So now they have given E value. E is equivalent to 2 by 3, that is the ratio between Vf divided by Vc. Okay, so we will be anywhere here in between the C to F distance, such that the V should fulfill this ratio. Vf should be 2 and Vc should be 3 parts. So totally we need 5 parts like this. Okay, so that Vf should be 2 and Vc should be 3 parts. So what I'm going to do is I'm going to divide the CF into 5 parts like this. Okay, so I have divided the CF distance into 5 parts, and I am fixing the vertex in the third. From C to V it is 3, and V to F it is 3. So V to F it is 2. Okay, so that our eccentricity ratio is fulfilled. 1, 2, 3. CV will be 3 parts and VF will be 1, 2 parts. Okay, so now I'm going to draw another horizontal line through V. Okay, like this. The end is called S, so that Vs is equal to Vf. Okay, so I've drawn a vertical line passing through V. That line is called Vs. This vertical line is called Vs, and the length should be equal to Vf. Now join the C and S and extend that line. Okay, like this. And then what we have to do is we have to draw parallel lines after V. Okay, at 10 mm distance or 5 mm distance, it's your convenient. Okay, so and name 1 1 dash for the first line, 2 2 dash, so the dash should be intersecting at the inclined line CS. Okay, 3 3 dash like this. And then what you are going to do is take the 1 1 dash as your radius, and F as the center, and F as the center, make a arc on 1 1 dash line. Okay, like this. And 2 2 dash as the radius, F as the center, make a arc on 2 2 dash line below and above the center line like this. This is the green line. Okay, sorry, green arc. And then 3 3 dash as the radius, F as the center, make a arc like this. And 4 4 dash as the center, F as the center, make a arc on 4 4 dash line. So by connecting all these points, you have to connect the vertex also, vertex point, first, second, third, fourth, and you can get an ellipse by connecting all these points. Okay, okay. So you have to draw parallel lines up to 10 or 11, 12, like that. You need to draw 12 parallel lines in order to obtain the ellipse. I have drawn only 4 lines. Okay, this is the method to draw an ellipse by using eccentricity method. The steps are given here. Okay, and then now we are going to draw a parabola, okay, in which the focus is 50 mm from the directrix. As I said earlier, you need to draw the directrix line and then the center line. Okay, and then you need to fix the focus which is 50 mm away from the directrix. Okay, now they have given, so they have not given the eccentricity value, but you should know the eccentricity value for the parabola is 1. Okay, so they have given here moving in a plane such that it's always remains equidistant from F and line B. Okay, so the point, this is the point which will move along the hyperbola. Okay, the ratio between CV and VF is equidistant. That means it is equal. They said it is equal. Then we need to draw the parabola. Okay, so since they said equidistance, E is equal to 1. Okay, anything divided by 1 is equal to 1. Okay, so E is equal to 1 by 1. So we need to divide it into two equal parts, so that VF should be 1 and VC should be 1. Okay, so I'm fixing the V, or I'm dividing this line into two equal parts, and then I've marked the V at the center point. This is first and this is second part. So in the middle I'm fixing the V. As we followed the step in the earlier ellipse. I need to draw a vertical line along the V. This length should be equivalent to the VF. Okay, VS should be equivalent to VF. So now I'm joining the C and S and I'm extending the line. Okay, and then we need to draw parallel lines after V. Okay, 1 1 dash 2 2 dash 3 3 dash. Okay, you need to draw parallel lines like this and name that line. Okay, so the 1 dash 2 dash and 3 dash is the intersection between the inclined line and the 1 2 3 line. Okay, and then 1 1 dash as the radius. Follow the steps we have followed earlier. 1 1 dash as the radius. Okay, this is the radius, and F as the center. Make a arc on the 1 1 dash line below and above the center line, and 2 2 dash as the center. Make a arc on 2 2 dash line above and below the center line. Similarly 3 3 dash. Okay, and now you connect all these points and you will get a parabola. Okay, now the hyperbola, the steps are same as we followed in ellipse and parabola. Here the e distance will be different. Okay, so they have given the e is 30, sorry, the point f is 35 mm away from the directrix. First I have drawn the directrix, and then the center line will be drawn, and then I am fixing the focus which is 35 mm away from the directrix. Okay, now they have given the eccentricity value. Eccentricity is 4 by 3, so it is given wrong. Okay, I'll correct. Okay, so it is given wrong here. Okay, I'm sorry. So instead of 4 by 3, it will be 3 by 2, so that we will get 5 parts. Okay, so the E ratio will be 3 by 2. So VF should be 3 parts and VC should be 2 parts. So totally I have to divide the 35 mm distance into 5 equal parts. I'm going to divide these distance between into 5 equal parts. So 1, 2, 3, 4, 5 equal parts. I have drawn 5 equal parts. Now I'm going to fix the V. Okay, VF should be 3 parts. You can see VF should be 3 parts. So 1, 2, 3. This point will be the V. Okay, so we can see I have fixed the V, and then we need to draw the parallel line after V. Oh, sorry. Before that, we need to draw a inclined line from C to S. This S can be obtained by drawing a vertical line from V, and the distance should be equal to VF should be equal to VS. So I have drawn the line, and then you can draw a inclined line from center point to S and extend. After this, you need to draw parallel lines after V like this. Okay, so now name the line 1 1 dash. Okay, 2 2 dash 3 3 dash like this, and take the 1 1 dash as the radius and F as the center. Make a arc on the first line. Okay, above and below. So this is the radius and F as the center. Make a arc on the 1 1 dash line above and below the center line. Similarly 2 2 dash as the center. Make a arc above and below the 2 2 dash line, and 3 3 dash as the radius. Make a arc on above and below line. So by connecting all these points through V, we can obtain the hyperbola. So this is the procedure to draw ellipse, parabola and hyperbola. Okay, now we are going to draw the tangent and normal for the curve for the ellipse. Okay, there is a small problem in this. The vertex will be here. Okay, the vertex will be here, so you should note this. This will be the center point. Okay, so now you need to draw the tangent and normal. Okay, a tangent is the point through which a line is passing through the curve. It should not intersect the curve, right? So take that point. So I've taken this point through which our tangent and normal will pass through. So the point Q is the point through which tangent and normal will pass. So I'm connecting Q and F. Okay. So Q and F is connected. For this line, I'm going to draw a 90-degree line which should touch the directrix. Okay. So for QF, I'm going to draw a 90-degree line and that line should touch the directrix. Okay. So I've got another point in the directrix. So from this point, I'm connecting the Q. Okay. First I have drawn this QF and then I've connected, or I have drawn a 90-degree line from F. You need to draw, you need to keep the protractor like this. Okay, for this line you are going to draw a 90-degree. So this will be 90-degree. So extend this line up to directrix and then you will obtain a point here. A point P will be here. Connect this point P and Q. Okay, this is the procedure to draw tangent and normal for the ellipse. Similarly, we are going to draw the tangent and normal for the parabola. Okay, so you can take any point on the curve. Okay, so a point is taken here. Okay, join this point Q and F. Okay, you have, you have drawn a line and then take the compass here and your 90-degree will, sorry, take the protractor here along this line CQF and then you will get a 90-degree line. Okay, so join this line up to the directrix. So another point you have obtained here, this point is called P. Okay, so join this P point and Q point, you will get a tangent, and 90-degree to the tangent, draw another line which is passing through Q, that is normal. A similar procedure can be followed to draw the tangent and normal for hyperbola. Fix any point on the curve, connect F, Q and F, and to this line draw a 90-degree line up to the directrix and then connect this point through Q and X, and that is the tangent line, and normal 90-degree to the tangent, draw another line passing through Q, so that is called normal. So this is the method to draw tangent and normal for the above set curves. Okay, so thank you.